In the last video, you learned about printing and if statements. Today, I'm going to talk more about events and other nodes in the engine. A node is a piece of code that represents actions, functions, variables, or flow control, and are connected to form a graph that determines how the game or application behaves. So every time you hear the word node, know that I'm talking about code in the editor. There's an ocean of nodes that you can choose from. Since it's not realistic or even necessary to learn what everything does, I obviously won't go through everything. Let's talk about some of the basic nodes that you will be using very often. First of all, code is executed in order. So whatever you connect first is what's going to happen first. Code has to start somewhere, or when something happens. This is what events are for. The begin play event happens when the actor spawns in the game. So if your actor is already in the world, it will happen when you press play. But if you spawn the actor later during the game, the code will run later when it spawns. Some nodes have something called input, and others have something called output. Some can even have both. Input means that it needs to take in a value, while output means that it will output a value. So the target, for example, is an input that needs to know what object to affect. The health variable is an output that feeds value to something that needs input. In summary, inputs can connect to outputs, assuming that their data types are compatible, but inputs can't connect to inputs, or outputs to outputs. To remove connections, hold in the Alt key and right-click with your mouse. The print code, as you know, is used to display text. A more specific way to put it is, printing is used to display values. This is useful when you want to know the value of something. Maybe a health variable, for example. If you want your code not to happen right away, you can use the delay node, which will intentionally delay the rest of the code until the time has passed. The time is counted in seconds or milliseconds if you are using decimals. If you have multiple lines of code that you want to happen in a specific order, you can use the sequence node. This node allows you to connect multiple lines of code at once. The sequence will execute the code in the order that it is put, starting from 0 and moving down. But the time difference is minimal. You can combine this with the delay node and choose exactly how your code should happen. We have another event known as a tick. What this does is essentially execute code every frame. So if you have 60 frames in your game, it will execute 60 times per second. This node is mostly used for testing purposes, or if you need something to be updated every frame, like a laser. The launch character node is a very fun node to use that launches your character in a given direction. There are 3 different vector values to set, the X, Y, and Z. I will go more into depth about vectors in another episode, but for now, just know that the Z-axis is up or down, the X value is forward or backwards, and the Y value is left or right. Then we have 2 booleans that we can check. This asks us if we want to add to our velocity or override it. So if we're falling, we may have a velocity of -100. If we don't check this, it will add 700 to 9100 and we will get 600. But if we check it, it will set the velocity to be 700 regardless. And lastly, we have input events. These are events that are called when a key is pressed. So using your keyboard, for example, you can execute lines of code when you press the U key, for example. Pressed will execute code when you press it, and released when you release the key. If we right-click somewhere in the editor, we get a menu that says All Actions for this blueprint. So in theory, this means that everything that shows up on the list is code that we can execute in this class. The code is divided into different categories relating to different parts of the class. If we enter the camera category, we get settings related to the camera. You will also notice that there are blue nodes and green nodes. In the last video, I explained that nodes are pre-made code that we connect in order for it to be executed. The green functions, however, are like pre-made equations that serve a specific purpose. So for example, the getVelocity node calculates our character's current velocity. You can imagine this to be like a math formula, and the return value gives us the answer to the calculation. These subnodes are not directly connected to be executed. Instead, they serve as an addition to our main code. These green equations are usually used to return a value. Returning a value is a process of getting a result or output and to be able to use that in some way. For example, if we search for get velocity, we get an output that can be connected to another node. This output returns the value of our character's current velocity in a vector variable format. Variables in Unreal Engine come in different colors to make it easier for us to understand. The current list is some of the most common variable types. This isn't something you need to remember, but it's very useful. You already know about integers, booleans, and floats, but there are a bunch more to know about. Each and every variable here has different properties and alternatives. So for example, we can do math like division or multiplication with integers and floats. But with integers we can only use whole numbers, but with floats we can use decimals as well. We also have integer 64 and byte variables. These are pretty much the same variable type as a normal integer, but they serve a different purpose. A normal integer can store values between 2 billion and negative 2 billion. But since this can take up a bunch of memory, we can choose to use something that can store less value, since we won't be needing to store that much value all the time. This is what the byte variable is for. We can only store numbers up to 255, and if we need higher numbers, we can use the integer 64. An integer 64 variable can store way more value. Then we have the blue variables. This can be a bit confusing, but these variables work a little bit differently. They store values of actors, objects, or components, and more. But the only thing you really need to know right now is that the blue variables represent objects. So every time you see a blue color, know that you need an object of some sort. This will make more sense in my upcoming videos. Next up, we have a class variable. This variable can store a class. You could use this to choose what character you wanted to play as, or something. The vector variable is used to store locations. You can choose between x, y, and z. The rotator variable stores x, y, and z values as well, but these values represent an object's rotation. So the z-axis, for example, rotates an object the same way you would rotate in real life. The transform variable is a mix of the vector, rotation, and another variable type known as scale. This is exactly what you think it is, and determines an object's scale. We can also split the transform value so that we can enter the other values separately. Lastly, we have the string, name, and text variable. These are exactly the same and contain characters like words or letters. The difference between them is where and how they're used. The name variable, for example, is used to reference skeletal mesh bones. So now you know about the most common variables. We will go more into depth as the series continues. So now, if you see something return a value, you can know what variable type it is based on its color. There is also an input required. This will usually be marked with a blue color. The blue color essentially means that it needs an object reference. In the camera example, you can see that our camera is being referenced in the parentheses. The engine assumes that we want to use this code for our camera. If we delete the camera component, the camera-related code is now gone. But some code can be general, like changing the location of a component, for example. The engine needs to know what component to affect, so that's what the target is for and why we need a target. Here, for example, we have two nodes that do the same thing. The difference between them is their target. The setActorLocation node targets actors, and since this current class is an actor, the self equals an actor. And the engine doesn't give us an error, but the setWorldLocation node targets scene components. So we need to specify the target, since self is not a scene component. So in this case, we need an object reference that is a camera component. Since objects can be anything in the game world, we need a camera in order to set the field of view. We can't set the field of view of a cube. One more way we can get an object reference is by searching it up in the blueprint list. If we search up the name of the object, in this case follow camera, it will show up. Notice how it automatically scrolls down for us. If we want to get the character movement reference, for example, it won't scroll down. We will have to do it manually. This is because there are many different things that contain the word character movement. It's a bit weird how it works. Just know that if you search something up, look for it properly. By the way, a nice trick that can save you some time. Instead of searching up the whole name, you can just search up some of the letters, like you could write camera. Or if you have something with a very unique name, you could just search up some of the last letters. Now, if we find our camera in the list, you will notice two options. One says get follow camera, and the other says set follow camera. So if we get the value, we will get the same type of object that we had before. Since we cannot do more with this current value than to get its value. Variables in Unreal Engine can either be referenced or be set. When we get a variable, we can only read its value, or, like you've heard this entire episode, return the value. But when we set the variable, we can change the variable's value in the code. This is useful for variable values that you know will be changed during the game. Like the character's health, for example. You would set it to be 100 by default, but when the character takes damage, you would need to set the variable. In order to take the right amount of damage, you need to read the current health variable and use math to either add health or take health. So you would get the variable to read its value. Let's say it's full and it's 100. Then you would set the variable to be 100 minus whatever value you would like to remove from the health. Objects are also variables, but they're not so easy to modify. A float variable can be set to be any number you need, but a camera object variable is set to be the camera that we have in the class. Setting this variable doesn't work the same way as the default variables. So to explain, the follow camera is an object reference, but it's also a variable. In the variables list, you will see that we can choose object as a variable type. Whether you choose the camera, or an integer value, or any other variable, you will have the option between getting the variable reference or setting the value of the variable. You may have noticed this context-sensitive box by now. This checkbox is used to determine whether we want to find code related to this class or not. You might be thinking, why would I want to find code not related to this class? If we open up another class that is not a character, and we search for launch character, you will see that it doesn't show up. If we uncheck the context-sensitive box, it will. But if we try to compile the code, we will get an error, because the target is not a character. So why would you want to use a node not specific to this class? This is a subject for another video, but, in short, there can be situations where you would like to communicate with another class. Maybe you want something to happen with your character when an actor class spawns in the game. You would use not context-sensitive code and find the right target type by referencing another class. We went through a lot of information in this video, so it could be useful to watch it again. But keep in mind that you don't have to remember everything. I am just mentioning a lot of these things so that they are in the back of your head. In the next episode, we will go even further into coding, and I will give you a little test to see if you have understood everything.